Hello, here we are again in, well, I say familiar surroundings, but it's slightly unfamiliar at the moment, isn't it? But all being well, we should be back soon. The reason I'm here is so I can demonstrate, as usual, which is why I do these videos, a practical situation. And what we've been looking at over the last 3 or 4 weeks is forces, different types of forces we've looked at. And the first time that we discussed forces, we looked at magnetism, and we looked at magnets attract or they repel, and we also made an electromagnet. And the electromagnet is over here, but the electromagnet picked up the clips because we put an electric current through the copper wire that goes around the nail. And some of you designed your own and sent them in. Fantastic. I've really seen some tremendous work. I've written some of the key words down that we've been looking at along the way, and they are forces, push, pull. Now, you've known for a few years now that forces are either a push or a pull. Then we did magnets, like I've just mentioned, attract and repel. I've probably missed something out here, which I can put in. What do you think they are? North Pole and South Pole. There we go. And that covers the magnetism. We also, last week, discussed friction. Now, can you see how this list's building up? I will upload this list onto Google Classroom for you. Now, friction, as we discussed last week, is when two surfaces meet. And a problem can be that things can get hot, they can overheat, or we can use it to our advantage, like I said last week with brakes on a car, to stop the car. So we talked about friction. This week, I'm going to discuss with you gravity. Now, gravity is what pulls us down onto the earth. We exert a force onto the ground, and it's due to gravity. If you jump out of an aircraft, gravity will pull you to the ground. That's why people use parachutes, otherwise they'd just hit the floor. And the up force going up to the parachute lifts the parachute, and then it balances and starts to come back down. Now, I'll give you some examples of forces, up thrusts and down forces, in a minute. But firstly, I want to just discuss that forces are measured in newtons. Now, we use instruments a lot in science to measure things. For example, if I want to know the mass is the correct word, of this cork, I would use scales. And that is 2.57 grams. Right? Now, grams is what we use for describing the mass of something. Now, if I want to measure the length of something, I would use a ruler. For example, this block of brass is 5 centimetres long. Centimetres, so grams for the mass, centimetres for the length. Now, it's quite warm in here today. It's usually pretty cold, but it's quite warm in here today, and this is what we use to measure the temperature of something. This is a thermometer. Now, you've used some of these yourself. You've used them when we've heated up water, and when I've shown you the Bunsen burner and how it heats things up, and we've used these. You've made, well, they're being used a lot at the moment, taking people's temperature. If they're too warm, they might have a problem. And that's a thermometer. They're used in all kinds of situations. And that is measured in degrees Celsius. So let's do a recap here then. So degrees Celsius is the temperature. Length, centimetres or millimetres or metres or kilometres, they're the units for that. And grams for the mass. Now, I mentioned earlier to you gravity. And gravity is what pulls us down to the ground. Now, there is also something else here, and it's called up thrust and down force. Now, the up thrust is what pushes up, and the down force is what pushes down. Now, if those two are balanced, then something will stay where it is. Right? For example, if I was to put this brass in this water, you've looked at floating and sinking in the past, but this is explaining it in more detail. If I was to put this brass in the water, what do you think would happen? Do you think the down force is stronger than the up force? Because if the down force is stronger, it will sink. So the down force is considerably stronger than the up force. So it's not balanced. Okay then, let's try something else. This is a block of wax. Now, do you think the down force will be stronger? The up thrust force will be stronger, or do you think it will balance? Let's have a look. That's slightly more of a down force than there is an up force, because it's more or less below the surface. Look, can you see that wax there? So I would say that isn't really balanced. It's floating, but eventually I think probably we could be looking at that sinking eventually. And this is the thing that they have to take into account when they're making boats, ships, anything like that on the ocean. Now then, we'll take these out because then we can see better. So we've established that the down force on that is stronger than the up force. We call it up force or up thrust, right? In fact, I'm going to write that on there next to up thrust so you'll know what it means. Up force. We'll call it an up force, right? There we go. So let's try something else then. What else have I got here? That is rubber.